Oh, AsyncTask, how we have a love-hate relationship with you. On the one hand, you make it really easy to get work off the main thread, but on the other hand, you make it really easy to do a bunch of really bad stuff. My name is Cole McCandless, and while AsyncTask provides some easy interfaces, if you're not careful, it can hurt your app's performance and end up causing memory leaks. So here's a familiar situation. The user wipes the screen, kicking off some bitmap decoding to occur. And because that work is going to take a long time, you need to hand it off to another thread so you don't cause hitching in your animations. But once the bitmaps have been decoded, you need to get them back to the UI thread so that you can update your views. If this happens a lot in your application, then it's not worth writing all the one-off code snippets to make this happen the right way. This is exactly why AsyncTask was created. It wraps up all of this gnarliness with 3 simple function calls. Basically, the onPreExecute function will happen on the main thread and allow you to set up the work you're about to do. Then the doInBackground function will execute on a worker thread, actually doing the computation. And finally, onPostExecute is called on the main thread along with the results of the work that you've just completed. Simply overload these 3 functions in your own class, and AsyncTask will do the rest. Now, while this seems like an ideal solution, you need to be cautious. There's some nuances with AsyncTask that can get you into trouble. Firstly, all async tasks that are created will share the same thread and thus will execute in a serial fashion from a single message queue. So if you kick off 20 work orders and the third one takes an hour, the other 17 will block and wait until it's done. This is especially dangerous if you kick off some work that's got a long-running while loop in it. Basically, it'll just freeze that thread from doing any future work. Now, to be fair, there is a way to force AsyncTask to execute in a thread-pooled fashion, but in reality, if you're venturing into that area, you might just want to use the thread pool primitive directly instead of all that madness. Anyhow, the second big problem might be a little bit more familiar. How do you actually cancel a block of work? I mean, AsyncTask has this handy cancel function, but what does that really do? Well, remember that threads don't directly contain the ability to interrupt the current code being executed. If you want a threaded block of work to be able to terminate early, you have to do 2 things. Number 1, add some logic to check for a flag that says the work has been canceled. And number 2, once the block of work is finished, let the other functions know that this packet's results are invalid. And this is exactly what the cancel function in AsyncTask does. It will set a flag and allow the isCanceled function to return true, so your code can check that regularly to see if it should exit early. In addition, after doInBackground returns, a canceled AsyncTask will call onCanceled on the UI thread instead of onPostExecute. This is so you can properly update your UI or destroy specific memory allocations that you might not need anymore, yada, yada, yada. And finally, be aware that it's really easy to leak memory with AsyncTask. Check out this very common, seen all the time code pattern in Android apps where an AsyncTask is declared as an inner class of some activity. This is a really big problem. Having AsyncTask declared as an inner class creates an implicit reference to the outer activity, which can then result in leaked memory, which means it won't be destroyed until the AsyncTask work completes. Obviously, this is less than ideal if you're trying to load a new activity and you still have several destroyed activities in memory since their work hasn't been completed. The gist here is that while AsyncTask makes it really easy to move work off the UI thread, it's far from being a silver bullet. So don't be afraid to check out some of the other threading primitives in Android in case you need a little different use case. For example, handler threads are great when you need a dedicated thread for callbacks to land on. Thread pools work best when you've got a mountain of small work objects to do. And intent services are really ideal for background tasks or when you need to get intent work off of the UI thread. And see, that's the whole thing when it comes to performance coding. You have to understand enough about the primitives to know how they might help you and how they might hurt you. And if it's not working, move on to a better pattern. Which is why you should check out the rest of the Android Performance Patterns videos. And don't forget to ask your hard threading questions in the Google Plus community as well. So keep calm, profile your code, and always remember, perf matters.